Hi, this is Praveen. Welcome to my channel Concept Classes. Today we are going to discuss about basic geometry for students mainly from class 6th and 7th grades. We will discuss about three topics. The first one will be types of angles, and then we will discuss about angles formed by the parallel lines, and then we will discuss a little bit about triangles and their types, and then triangles properties. So let's get started. First we will discuss about acute angle. What acute angle is? We already know that if the measure of an angle is less than 90 degree, the angle is called as acute angle. For example, here we have an angle and which is x degree, and if we measure this x degree, it will certainly come as less than 90 degree. So this angle will be called as acute angle, as simple as that. And then we have a right angle. If we measure the value of an angle, and if it comes equal to 90 degree, then that angle is called as a right angle. For example, in this angle the value of x degree is exactly equal to 90 degree, so this angle will be called as right angle. And then we have obtuse angle. If the value of the angle, if the measure of the angle is more than 90 degree, however less than 180 degree, the angle is called as obtuse angle. For example, in this angle the measure of x degree is more than 90 degree and less than 180 degree. If we measure the value, it will certainly come as more than 90 and less than 180, so this angle will be called as obtuse angle. And then next type of angle we have is a straight angle. So if the value of an angle is exactly equal to 180 degree, that angle is called as straight angle. So when two arrows originate from same place in opposite direction, the angle formed by that is called as straight angle. Here x degree is equal to 180 degree, so it will be a straight angle. And next we have reflex angle. Like if we measure the value of x degree this way, if the two rays originate from the same position in this fashion, and if we measure the value of this angle will certainly be more than 180 degree, however less than 360 degree, so this angle will be called as a reflex angle. So whenever the measure of an angle is more than 180 degree but less than 360 degree, the angle is called as a reflex angle, right? Now we will discuss about complementary angles and supplementary angles. What is complementary angles and what is supplementary angles? So complementary angles, when the sum of two angles is equal to 90 degree, then both angles are called complementary angles. For example, if we take two angles for x and y, and if we add them, and if the value of these two angles come as 90 degree, then these two angles will be called as complementary angles. And we can say x is the complementary angle of y and y is the complementary of x. So for example, if we take the value of x like 30 degree and y as 60 degree, and if we add both these angles 30 plus 60, it will be 90 degree. So we can say 30 degree and 60 degree are complementary angles, right? Similarly, if we add two angles and if their sum is equal to 180 degree, then those two angles are called supplementary angles. For example, if we have two angles a plus b, and if we add them and if it comes equal to 180 degree, then angle a and angle b will be called supplementary angles. A will be supplementary of b and b will be supplementary of a. Now what is linear pair? So angles formed by drawing another line on a straight line are called linear pair. Like let's see this is a straight line, and if we draw another straight line on this straight line in this fashion, so now we have two angles formed due to drawing a straight line on another straight line. So these two angles will be called as linear pair, right? If we name these angles, like the straight line was AD and then we draw another straight line OB, so we have two angles, angle AOB and angle BOD. Angle AOB is the first angle BOD is the second angle. So angle AOB and angle BOD are linear pair here, and sum of angles in a linear pair is supplementary. So whenever there is a straight line and if we draw another straight line on that straight line, we have two angles and those angles will be called as linear pair, and when we add those two angles their value will come as 180 degree. So that is why they will be called as supplementary. Here angle AOB plus angle BOD will be equal to 180 degree. So angle AOB and angle BOD are supplementary to each other, right? Now we will discuss about parallel lines and transversal. Here we have drawn two lines AB and CD. These two lines are drawn in such a way that they will never meet each other, and that is why they will be called as parallel lines. AB is parallel to CD, right? So here AB and CD are two parallel lines, and then we have drawn another line XY which is intersecting both the lines AB and CD, and this XY will be called as transversal of AB and CD. So like what is transversal? The transversal line is a line which intersect two parallel lines. So here AB and CD are two parallel lines and XY is the transversal. So when there are two parallel lines intersected by another line, there are so many angles formed due to that, and these angles have different names and different properties. So we will discuss about that, right? So the first angle we will discuss about interior alternate angles. So here interior alternate angles are 3 and 5 and 4 and 6. This angle 3 and angle 5 and angle 4 and angle 6, these are interior alternate angles. So angle 3 and angle 5 are equal and angle 4 and angle 6 are equal. So interior alternate angles are equal when the two parallel lines are intersected by another line which is called transversal. In that case interior alternate angles are equal to each other. So here angle 3 will be equal to angle 5 and angle 4 will be equal to angle 6. Similarly exterior alternate angles are also equal. So here exterior alternate angles are angle 1 and angle 7 and angle 2 and angle 8. So angle 1 is equal to angle 7, angle 2 is equal to angle 8, because exterior alternate angles are also equal. Now we have corresponding angles. What are corresponding angles? So angle 1, angle 5, angle 2, angle 6, angle 4, angle 8 and angle 3 and angle 7. These angles are corresponding angles, and corresponding angles are also equal. So because corresponding angles are also equal, we have angle 1 is equal to angle 5. So this angle 1 will be equal to angle 5, angle 2 will be equal to angle 6, angle 4 will be equal to angle 8 and angle 3 will be equal to angle 7, because corresponding angles are also equal when there are two parallel lines intersected by a transversal, right? And then we have vertically opposite angles which are also equal. So vertically opposite angles, angle 1 will be equal to angle 3, angle 2 will be equal to angle 4, angle 5 is equal to angle 7 and angle 6 is equal to angle 8. And then we have exterior angles on the same sides of transversal are supplementary. So this is the transversal XY, and exterior angle on the same side are this angle 2 and angle 7, and this side we have angle 1 and angle 8. These are the exterior angles on the same side of transversal, and exterior angle on the same side of transversal are supplementary, which means their sum is equal to 180 degree. So exterior angle on this side of transversal, left side of transversal, are angle 1 and angle 8. So angle 1 plus angle 8 will be equal to 180 degree. Similarly, angle 2 and angle 7, if we add them, angle 2 plus angle 7, it will be equal to 180 degree also. And similarly, interior angles on the same side of transversal are also supplementary. So interior angle on the left hand side of the transversal are angle 4 and angle 5, and interior angle on the right hand side of transversal are angle 3 and angle 6. So angle 3 plus angle 6 will be equal to 180 degree, and angle 4 plus angle 5 will also be, if you add them, we will get 180 degree because they are supplementary, right? So after discussing about parallel lines and their properties, we will discuss about types of triangles now. So the first type of triangle we have is equilateral triangle. On the basis of sides, we can have three types of triangle: equilateral triangle, isosceles triangle, and scalene triangle. So the first is equilateral triangle. If all the sides of a triangle are equal, the triangle is an equilateral triangle. So for example, in this triangle ABC, this side AB is equal to side BC is equal to side AC. So these three sides are equal to each other. That is why this will be called as an equilateral triangle. And in an equilateral triangle, because all the three sides are equal to each other, the three angles will also be equal to each other. That is why the measure of all these three angles will be equal to 60 degree. So this angle A will be 60 degree, angle B will be 60 degree, angle C will be also 60 degree, because we know that sum of all angles of a triangle is equal to 180 degree. So in an equilateral triangle, all the three sides are equal to each other, and hence all the three angles are also equal to each other, which is 60 degree. And the next one is isosceles triangle. If two sides of a triangle are equal to each other, then the triangle is called as isosceles triangle. Here side AB is equal to side AC. So side AB is equal to side AC. That is why this triangle is called isosceles triangles. And in an isosceles triangle, angles opposite to equal sides are also equal. So in this triangle, this side AB is equal to side AC, and angle opposite to side AB is angle C, and angle opposite to side AC is angle B. So angle B will be is equal to angle C. So angle ABC, this angle, will be equal to angle ACB, this angle, because in an isosceles triangle, the angles opposite to equal sides are also equal, right? So in an isosceles triangle, two sides are equal to each other, and hence two angles are also equal to each other. And then the final one is scalene triangle, in which no side is equal to any side. So in this triangle, angle side AB is not equal to side BC, is not equal to side AC. So no side is equal to each other, so no angle is equal to each other. That is called scalene triangle. And we already know that in a triangle, if we add all the angles, it will come as 180 degree, right? Now on the basis of measurement of angle, we also have types of triangles. So the first one is acute angle triangle. If we measure the value of the triangle, value of angles of a triangle, and if all the angles are less than 90 degree, then that triangle will be called as acute angle triangle. For example, in this triangle ACD, angle DAC, this angle is less than 90 degree. Angle ACD, this angle is less than 90 degree, and angle ADC, this angle is less than 90 degree. So all these three angles are less than 90 degree, so this angle will be called as acute angle triangle, right? And what is right angle triangle? So in a triangle, if the measure of one angle is equal to 90 degree, so that angle will be called as right angle triangle. So here in this example, triangle PQR, angle PQR is equal to 90 degree. So angle PQR is equal to 90 degree. So this angle, this triangle is called as right angle triangle. Alright. And the next one is obtuse angle triangle. In an obtuse angle triangle, if the measure of one angle of the triangle is obtuse, which is more than 90 degree or less than 180 degree, then that triangle is called as obtuse angle triangle. In this triangle, measure of angle XYZ, that is XYZ, this angle, measure of this angle is obtuse, which is more than 90 degree but less than 180 degree. So this triangle is an example of obtuse angle triangle. Now we will discuss about one theorem which says that sum of all angles of a triangle is equal to 180 degree. We already know that when we add all the angles of the triangle, it comes equal to 180 degree. So now we will try to prove that same, right? So let's say we have a triangle which is named as ABC. So we have this triangle ABC, and we have to prove that angle ABC, that is this angle, plus angle BAC, that is this angle, and plus angle ACB, that is this angle, if we add all these three angles, it should come equal to 180 degree. This is what we have to prove, right? So to prove this, what we will do, we will draw a line XY parallel to side BC passing through A. So we will draw a line parallel to XY like this. This line XY is parallel to this line BC passing through this point A, right? After drawing this line, what we can see, that angle XYB is equal to angle ABC. Why? Because interior alternate angles are equal. Let's see. Here angle XYB, this angle XYB, this angle is equal to angle ABC, this angle, because this angle ABC and this angle XYB are interior alternate angles, because this line XY and BC are parallel to each other, and this AB is acting as a transversal for these two lines. So angle XYB, this angle is equal to angle ABC, because interior alternate angles are equal to each other. Similarly, we have angle YAC, this angle YAC, this angle is equal to angle ACB, this angle. Again the same reason, interior alternate angles are equal to each other. In this case, again BC is parallel to XY, and in this case AC is acting as a transversal line, right? So we name this equation as 1 and this one as, and also we have angle XAB plus angle BAC plus angle YAC is equal to 180 degree. sum of all angles on a straight line is equal to 180 degree. We already know that on a straight line, if we add all the angles formed on a straight line, their sum will come as equal to 180 degree. So from that we have angle XAB, this angle, plus angle BAC, this angle, plus angle YAC, this angle, their sum is equal to 180 degree. We have this as equation number 3. So now putting 1 and 2 in equation 3, we get, when we put the value of 1 and 2 in this third equation, what we get? We get angle ABC plus angle BAC plus angle ACB is equal to 180 degree, and that is what we wanted to prove. So angle ABC, this angle, plus angle BAC, this angle, plus angle ACB, this angle, has come equal to 180 degree, and hence it is proved. Now we'll prove one more theorem of geometry, which is called as theorem number 2, and it is exterior angle of a triangle is equal to sum of its opposite interior angles. So let's try to understand this theorem and then we will try to prove it. So we have a triangle called PQR. This is the triangle, and let's extend the line QR to point S. So now the diagram will look like this. In this triangle, angle P, that is angle QPR, this angle PQR, this angle, and angle PRQ, this angle, these are the interior angles of the triangle, right? Already we know that these three angles are the interior angles of the triangle, but this new angle, which is angle PRS, this angle is called as the exterior angle of this triangle. So we have to prove that the exterior angle of this triangle is equal to the sum of its opposite interior angles. So we have to prove that angle PRS is equal to angle PQR plus angle QPR. So to prove this, what we already know, that angle PQR plus angle PRQ plus angle QPR is equal to 180 degree, because we already proved in the previous theorem that sum of all angles of a triangle is equal to 180 degree. So from there we already have this equation, and we call it as equation number 1. Now what we also know, that angle PRQ plus angle PRS is equal to 180 degree. This angle PRS and plus PRQ, this angle is equal to 180 degree, because sum of all angles on a straight line is equal to 180 degree. We take this as equation number 2. So now from 1 and 2 we have angle PQR plus angle PRQ plus angle QPR is equal to angle PRQ plus angle PRS, because in the first equation this is equal to 180 degree, and in the second equation these two is equal to 180 degree. So from LHS to RHS we can say that this entire LHS is equal to this angle PRQ plus angle PRS, right? So now we can see that angle PRQ is common in both LHS and RHS. Angle PRQ is common in LHS as well and in RHS as well. So we can cancel angle PRQ. So the PRQ can be cancelled, and when the PRQ is cancelled, what will are left with is angle PQR plus angle QPR is equal to angle PRS, and that is what we wanted to prove, that angle PQR plus angle QPR is equal to angle PRS, and hence it is proved. So that's all for now. I hope this video was informative for you, and I would like to thank you for viewing this.